voice to a face now. We are going to be looking at a couple of different math-inspired activities to see how we can start engaging our students with the Common Core and mathematical practices. A couple of the ones that we're going to be taking a peek at have to do with domain and range, and that's one of those topics that we really want our students to have a good handle on as they move up through our courses. Transformations of functions, which we all know sticks with us throughout the entire math sequence. Graphic designing and transform functions. You're going to see some really incredible student work this evening and learn ways that you can kind of bring this into your own classroom and make it fun and motivating for your students. We're also going to look into solving systems by graphing and find out where we can find all of these resources free online, already pre-made and ready for us to use in our classrooms.
Thanks, Audrey.
You're welcome.
Blake is going to discuss our expected outcomes. Blake?
Thank you, Mike. Well, by the end of this webinar, we hope that you can see how these math-inspired activities can help students learn more about these core concepts in Algebra 1. And we also want you to learn how to use the TI-Nspire technology to help students make visual connections to piecewise and step functions. We're going to talk about identifying some misconceptions regarding those transformations of functions, and also talk about how you can stay in touch with social media and some additional upcoming events that will be happening in the very near future.
Great. Blake, if you don't mind sharing your desktop. And as Blake does this, you'll notice that the right side of your screen, which housed the chat window and the Q&A window, moved to the top portion of your screen underneath that green floating toolbar. So at any point, feel free to ask any questions, and we'll try and get those questions answered live. As well, I know that Audrey and Blake have some really great engaging questions to ask you, and we're probably going to be using the chat window to respond to that as well. So without further ado, Audrey, take it away.
Okay, so the first thing we're going to talk about this evening is domain and range. And what I wanted to do is I wanted to take a look at a file called Domain and Range 2 that kind of deals with different types of functions that we generally haven't seen in an Algebra 1 classroom that may be new to us coming with this Common Core. The Common Core standard that I felt this best represented was students learning how to use tools strategically. The great thing about Common Core, it really does kind of make it student-centered instead of teacher-centered. So we're really allowing our kids to, I guess, get their hands dirty with this type of stuff. So that's what this file is going to revolve around. Could you go to the next slide, or the next page for me, Blake, please? Thank you. Okay, so this first slide is pretty simple. We see a whole bunch of points, and then what the first thing kids see is color. Okay, so this is kind of where we have to begin. We have to let the students figure out what's going on. Make the connection between the color and between down at the bottom where it says grab and move point P, and then it has in blue 3 and in red -2, kind of getting an idea of why those are blue and red and how that correlates to the red and the blue on our axes. So what you're going to have your students do is you're going to have them go over to point P, and they're going to grab that point. Now, if you don't know how to grab a point, it's actually very simple. All you have to do is you're going to click Control and then your center click on that nav pad. Now, because we're using software, we're going to grab it just using our cursor. And if you have a smartboard or an interactive whiteboard, you would do the same thing. So we're going to grab that point P, and we're going to move from point to point. There we go. And as we see, as we move from point to point, things are happening. We're having these blue and red points being plotted on our axes. So if you want to just keep moving from point to point, move all around for me, Blake, and we get all these red and blue dots. So what we're going to ask our kids to do is we want them to draw a conjecture as to what the purpose of all those dots are. Why are they there? Knowing that we're talking about domain and range to begin with. and why I say let them draw the conjecture is when students come up with the knowledge, when they come up with the idea, they own it, and they tend to keep it that way. So this is a really nice way for them to start thinking about the connection between the x-axis and domain and the y-axis and the range. So this is a very, very simple idea with the points. Can you go to page 2.1 for me, Blake?
Certainly.
Thank you very much. All right, so we've got a nice cubic here. It is restricted. The domain is restricted, so it gives us a nice restricted domain and range to kind of work with. And what I really like to start to do is once my kids start to grasp this concept of domain and range, this file really drives it home. So if you want to go ahead and pull that point P along the cubic function, that would be awesome. And what we're noticing is, as we move along this cubic, we've got that red tracing along your y-axis representing your range, and the blue tracing along the x-axis representing your domain. So what I like to do from here is now allow my students to start using interval notation and describing the domain and range using interval notation. So again, it's a really nice way for them to visualize what that domain and range are. Okay, so that's a cubic. That's kind of a new one for us in Algebra 1. We do believe that they're going to be seeing these higher order polynomials, so this is a really nice way to extend domain and range onto that. If you have any questions, feel free to use that Q&A. I'm waiting to see stuff pop up, so don't hesitate. Can you go to the next page for me, Blake, please? Okay, so this is a step function. Now this is also one of those ones where we're going to start seeing this in Algebra 1. And this is actually a beautiful representation because we have that open circle, right? We know that the function doesn't exist there. So as we go ahead and we pull that point P, we're going to see something interesting happen. Our first thought may be, oh, well, I'm going to have holes in my domain. But what the students start to grasp from this or start to understand is even if that value doesn't exist, the next step up, it exists. So they start to understand how the domain is actually continuous, where your range is step by step by step. So this is a really nice representation. Blake, could you open up the student document that goes along with this TNS lab, please?
Yep.
Now, if you really want your students to kind of work independently, I like to have them in pairs for this because I really enjoyed hearing the conversation. And believe it or not, they will have great in-depth conversations about domain and range if you let them just go with it. So this is a file that comes with the activity, and this is a student activity. It does come in a doc and a PDF. And what you can do is you can hand this right over to your students and say, okay, it's time to play. And they enjoy that. As long as they know how to grab and move something, they can fly with this. And they will work through it. They'll work through it together as a pair. And it literally walks them step by step by step on what kind of questions. It draws out the kinds of things that you normally as the teacher would be upfront telling them. So this is a nice document that goes along with this. Any questions so far? Everybody's quiet tonight. Okay. You want to go back to the document for me, Blake? Thank you. 3.2? I'm sorry, 4.1, I guess. Okay. All right, so now this file, or this page is actually very important because we see something unique with this function that we didn't see in terms of the other ones. Can anybody tell me what it is in that Q&A? I'm going to force you to use it here. What do we see that's unique on this page that we have not seen on the others? Anybody? Blake, what do you see?
Well,
oh, absolute value. Great. I like that. All right, now we're starting to pop in. Say the question again. Okay, so what is unique to this page that we haven't seen on the other pages? There's something, well, I guess we saw it in piecewise, right? What's here that we really want our students to pay attention to? Interval is unbounded on one side. That is wonderful, yes. Okay, if you were one of my students, I'd throw you a Jolly Rancher. Who else? Domain goes to positive infinity. Great. Okay, so all of these things now, if I'm the teacher, that's the question I ask, and I let my students come up with all of those responses. I am not up there telling them domain goes to positive infinity, interval is unbounded on one side. I'm letting them tell me. So these files really start to stretch that and really allows your students to take responsibility for their learning. So if you want to go ahead and pull that point for me. And I really like this part right here. What do we notice on that domain? We have that open circle, right? That knowing that my domain doesn't exist there. So if we stretch that all the way down now, we should see it kind of spike out to positive infinity. Excellent. So notice when we hit that, the bottom of that screen, although we had to stop with our cursor, our domain didn't. Okay, so that's something else that we're going to allow our students to discover instead of us telling them. Okay?
Audrey,
all right. Yes.
What does this little arrow on the side do?
That's our reset. Why don't you go ahead and click it and find out. It allows us to start over, which is great because if they don't get it the first time they pull that point around, they can do it about 100 times after that until they do. So that reset is a very nice feature. Okay. Why don't we skip ahead to 6.2, Blake? And he's turning the page by hitting Control over on his nav pad. So that's another way. Or you can use your thumbnails. The way you access your thumbnails is by hitting Control up arrow, and it brings us to this pretty kind of access place here. So you can get to pages very quickly. Okay. So this last page is really nice. It seems really like boring. You don't know what to do with it on first look. So what you're going to do as the teacher now is you're going to ask your students to create something that fits with a domain and a range that you give them. So if your kids are working in pairs, you can go around from each pair and give them a restriction on domain and range. Say you wanted your domain to be from -3 to 2 and your range to be from -1 to 5. And allow your students to create the function that fits that domain and range. And then what I would do as an educator is if you have something like, if you have TI-Nspire Navigator, you could screenshot your classroom and pull up a bunch of different examples of different ways students created possibly the same domain and range, because we know many different functions can satisfy that. So it's a way for students to really start creating and understanding how to work these things. So you can pull those points right around, you can move things up and down, whatever you'd like to do to adjust. Can we remind you how to download files? Yeah, that's a great idea. Okay, in order to download files, there's a few ways to do it. We are going to show you how to download files from Math Nspired. Blake, do you want to do that now?
We can.
Do you have that open?
I don't have the website open. Could we show them the content workspace and
Absolutely.
then maybe come back to the Math Nspired?
That sounds like a great idea. Okay, so on your content workspace, this is if you're in your software. You can go ahead and click on it, and it's going to bring you to kind of a different looking screen. On the left-hand side, you see where it says activities, it says web content, activities exchange, Math Inspired, and Science Inspired. We're going to stick with Math Inspired tonight. Math Inspired is really an incredible place for pre-made, ready-to-go files. So if there's a specific one that you would like, subject, you would probably want mathematics unless you're going with something else, which is good. Topic is whatever you're looking for. Algebra 1 would be the case for this evening. And let's say we want, for category, functions and relations. Okay? So once you find your document, and it's not going to be there for us because it's in a different spot than one we're looking at, but we can pick any one of those. Function or not a function. And what you'll notice is underneath, it's going to actually open up where Blake's cursor is right now down in that bottom section. To the right, you see Save this activity to computer, and you can actually click right on that and save it to wherever you would like to save it. So that's a nice, quick, easy way to find your documents. Okay? Teresa, I hope that helped. Okay. All right, Blake, if you want to go back to your document tab, I think we're going to put it over to you now, Blake. If you want to go ahead.
Certainly. Okay, so the next activity we're going to take a look at is one titled Transformations of Functions. And this is a very big concept in Algebra 1, as we all know. And so I have a discussion question I would like to pose to everyone. I would really like you to post your responses within the chat room. But this question is, what are some common misconceptions students have regarding transformations of functions? I'll give y'all maybe a minute to post your responses there.
Blake, while they're doing that, I thought maybe I could share some of my students' issues when learning transformations of functions.
Certainly.
So normally I start dealing with looking at parent functions, and they always really seem to get confused with, you know, which parameter controls the horizontal, what controls the vertical, and that's usually like step one of confusion for them.
So understanding what those variables H and K control in I guess in the general form of some of these functions. Well, let's go ahead and take a look at this activity and see if this might help address possibly that particular misconception. And this activity is available through the Math Nspired website. And like all TI Math Nspired activities, the first page in the document is going to be the title page, and it'll have the title and then a brief description of the activity. I'm going to go ahead and move to page 1.2. And on this particular page, we really have a kind of a split screen here. On one side, we have a slider, and this slider is going to affect our function in some way. And then beside that, we have the window here that has our function. I'm going to go ahead and manipulate the slider so that you can see what happens as we manipulate the slider. And then we'll talk about why this is built or why it might be built a certain way, and what are the benefits to having this activity constructed in this way. A couple of things I'll also point out to you. Down at the bottom, we have another representation of this function. We've got our graphical representation here. Down below, we have our algebraic representation. And right now, we're just defining this function as f of x. But notice as we move this slider up, there are some things that are happening in the graph, and then there's also some things that are happening down here with the text. Okay? Now, it's no coincidence that this slider is positioned vertically. What is the benefit to that? How does that impact the student's learning or the student's understanding? How might it impact their understanding?
So they're seeing the shift as a vertical shift, and they're actually making the motion of a vertical motion along that slider. So making that connection is very important, and seeing the changes to where we are affecting the equation as well.
Absolutely. Absolutely. Okay, so let's take a look at the next page in this document. Here, again, we see a document or a page that looks relatively similar. In fact, the graph looks almost identical. Notice now, though, that my slider is positioned horizontally. So what do you think might happen in this case if I shift my slider? I see a couple of people saying that they think it's going to give us a horizontal shift. And let's see if we're correct. So I'm going to move my slider to the left. And those predictions were correct. I'll move my slider to the right. You can see what's happening. Now, notice the representation down here at the bottom of this screen. It's also, again, it's adjusting this value. But there's a difference between the way that we have this notated as, in this case, it's f of x minus 3, and over here on this other page where we were looking at the vertical shift, this constant is outside of the function definition. Okay? Now, something that I would point out to you that would be a good practice if you do this activity with your kids, and it's exactly what I was really trying to model with you all in this demonstration, is before your students manipulate the sliders, and this can be applied to not just this activity, but many of the activities on Math Nspired. And in fact, in a lot of the student documents, they're asked to make a prediction before they do something. That's very, very important for our students to be able to develop that kind of thinking, to make a prediction about something and then test something out and then observe what happens as they manipulate a variable, what happens to the graph, what happens to the function, and then determine whether or not their prediction was true. Let's take a look at another page with this. All right, so on page 3.1, now we're going to combine both a horizontal shift with a vertical shift. And the benefit to that is now we can look at this representation down at the bottom, and we can see within the same screen or within the same window what is being changed as I change these values for H and K. Which of those constants is it affecting? Here's another pedagogical question for everyone, and I would love to see your responses in the chat window. You'll notice on all of these pages the two different representations of the function. We have the parent function that is identified with this dotted line, and then the transformation, which is the solid line. Both of these are in the same color. What is the benefit, or what might be a good pedagogical reason for having those in the same color?
Students really start to make the connection between the parent function and the transformed function, understanding that we're actually creating that new function from the original, from the parent function itself.
Right. Because the idea here is to really look at the relationship between the two, looking at the relationship between the parent function and the transformation. Thank you, Audrey.
You're welcome.
Okay, I think at this point I want to bring up something. Based on what we've looked at so far, which of these 8 Common Core mathematical practices could you say that we have addressed or that we have touched on just in the demonstration of these activities?
Well, I think we have used appropriate tools strategically. Yeah, see, 2, 3, 4, 5, 6, and 7. Awesome.
Yeah.
I would say so.
And if I can
and you really do start to kind of build each and every one of these into your lessons without even really realizing that they're in there. They start to actually become part of your teaching methodology.
Yes, they do.
Agreed. And I think, if you don't mind me jumping in, this is Mike Houston. I think one of the nice things about whenever I've been using, for instance, like that domain and range activity or transformations activity is really, I guess, how little work I'm doing, but how much work my students are doing.
Very good point, Mike. These activities are really designed to fulfill these 8 Common Core mathematical practices, along with the content standards that are written into the Common Core state standards. And we all should keep in mind that those are written for what the students should be doing, not we as teachers, but what the kids should be doing. These activities that are on Math Nspired are wonderful opportunities for your students to engage in these types of practices as it relates to those mathematical concepts and the mathematical content that they have to learn. Okay. I think for time's sake, Audrey, do we want to move on to the next piece?
Sure. Yep.
Okay.
We're going to look at the piecewise functions.
Yes, we are. I'm
Okay.
going to start from a new document. And to do that, I just hit the home screen. and I'm going to go to New Document.
There's a couple of ways you can do that when you're at your home screen. In order to move around that home screen, you can hit your Tab button, or you can hit the number 1, and that will bring you automatically to a new document. So there are a few ways. You can even swipe and click like you would on a laptop. So the students will pick their own way. Each of them will do it differently, whatever works for you, but there are multiple ways to navigate around this home screen.
And I'm going to say no, I don't want to save the changes. Just kind of on a side note, if you're doing these types of activities with your students, and especially in a classroom or a setting where you have multiple classes during the day, most of the time you won't want the students to save those files on the handhelds because it will save their responses or the changes they make to those files. So typically you want to get your students in the habit of not saving the changes on the handheld.
Mm-hmm.
Okay, so we're going to create a new graph, and we're going to move into some piecewise functions and how to, a quick way to graph piecewise functions. One of the really nice things about the Nspire is the use of the math templates. And so this button right here that's just below the delete key, this is my math templates button. And when I press that,
awesome key.
They call it the what key?
The awesome key.
The awesome key. It is
yes,
an awesome key because look at all of the things that we have readily available to us, literally at our fingertip, with the press of that button. We've got stacked fractions template, exponents, square roots, nth root, natural log, and so on. And then we have these two right here. And for time's sake, let's see. I'm going to do just a two-piece piecewise function. Yes, somebody said matrix buttons also. Yes, see the matrix buttons down here. And for those of you that might teach calculus, you do have a derivative template as well, which is very handy. All right, but we're going to focus on this template right here, which is the two-piece piecewise function. And so let's see, I'm just going to do a couple of simple functions. Let's see, 2x plus 4. So as I'm doing this, let me just kind of describe what you're seeing. You can see there's two levels to this template. The top level is for my first function, or I'm just going to call it my first function. And then the bottom level will be for my second function. And then there are two sections. The first section is where I define the functions, where I put the expression that defines the function. And then beside that is where I am going to be able to restrict the domain. So in this case, I want to say such that x, such that x is less than, or -4 is less than x. And then I'll come over and define my next function. And let's say that we want to do this such that x is greater than, no. Okay. And you can see it's defined these functions and graphed them based on the domains that I have defined.
Now, Blake, with our second part of our piecewise, the x minus 2, we have our domain restricted to x is greater than 2. Now, normally when we ask our students to graph these, say, on paper, we would like them to include or to show that that part of the piecewise doesn't exist at 2. Now, on the calculator, that's not as defined as we would like to see it on paper. So we do have to sometimes remind our students to kind of extend past this just visual phase and go a little bit deeper. So what do you think that we would need them to do? What's missing here?
From the function definition?
Well, not from our function definition, but from our graph itself. So normally if we were to graph this on paper, I would like my students to include something at the value of 2. Yeah, label the graph, absolutely. I 100% want them to label that graph. But at that value of 2, we know that it doesn't exist, right? We want where it's greater than 2. So normally we would have them have an open circle at that value. Now for them, when we look at it, yeah, open, closed circles, those become incredibly important to us. So when we look at it visually, that's going to be hard for our students to see. So we have to make sure that we go a little bit further and not just look at the graph.
Right. Which brings up the importance of having those in-class discussions with an activity such as this. I do want to show one other capability right here. Some of you may know about this. There may be a few of you that haven't seen this before. But I can double-click on this function right here. And when I do that, it's basically a text box. And I can come in and using my, if I'm on my handheld, I can use my arrow keys on my touchpad to do this. And I'm going to change this piece of my piecewise function to, let's just make it quadratic. And now I'm going to press Enter. So what has happened here?
Oops, where'd it go?
Someone has asked if we can zoom, can we get it back? To zoom, I can press Menu, and good, someone notified me that the range is outside the window. So what would I need my window settings to be to accommodate for this? I'll come back to the screen, the graph itself. Let's see, if x is greater than 2, then this is the function that I'm going to use, and it's 3x minus 2, 3x squared minus 2. So let's just see. I'm going to go to my window settings, and let's just adjust my Y max to 30. So it's still there, but it was outside of the window because of the range. And so that's another way that you can have the discussion with your kids using the technology, even taking this activity and tying it back to the concept of domain and range, simply by thinking about things with your window settings and asking questions and purposefully maybe even giving them something to graph that's going to be outside the given window, and then asking them to think about the range or think about the domain and use that as a starting point for their window settings.
Now, Blake, with my students, I saw that you used menu window settings. With my students, what I have them do is I have them double-click on, let's say, the Y maximum. If I double-clicked on the value of 30, that will open a text box, and they can change the window right from there. If they wanted to make that, say, 60, they could make it 60 and then hit Tab, and it would bring them now to the X maximum, so they could continue to adjust this around and around and around until they get it right. I know myself, I'm a very visual learner, and this is a nice way to kind of have the kids understand what that X minimum, X maximum means and why it's so important.
Excellent point. Thank you, Audrey. Okay. Audrey, do you want to show them the step functions?
Sure do. Okay, so we're going to look at a few step functions here. Now, we are going to start a new document. I'm wondering, does anybody remember how we start a new document? Let's see if I can get any takers here. How do we start a new document? I'll give you a hint. She's hovering over the key. Okay, go ahead and hit that home key. And we are going to either swipe or press the number 1 or hit your tab, home 1. Awesome, thank you. So we're going to start that new document. And since we're still going to be graphing, we're not going to save changes. And we're going to add graphs. Now, the first time this year I had to teach step functions, I was searching and searching and searching for a template, thinking that that's what I needed to use because it had been the first time that I was teaching it using the Nspire. So I had to do a little figuring out, and to graph step functions, we actually have to enter it a little bit differently than the way we see it. So in order to graph, let's just say, the basic step function, you actually are going to type in int, standing for our greatest integer, so int, and then in parentheses you're going to put x. So open parentheses x, close parentheses. And what's nice about the Nspire is it automatically closes that parentheses for us. We don't need to do it ourselves. So go ahead and hit enter. And it's going to graph our step function. Okay? So that's the quick, easy way to graph a step function, and it's very nice looking. Now, keep in mind that, again, we know that normally if we were to graph this on paper, we'd have those nice open circles, right? We don't see those here. So what I want to do to kind of allow the kids to see that this function works a little bit differently than it looks is I want to actually do a graph trace here just so you can see how this is working. So we're going to hit Menu, Trace, which is option 5, and we're going to do a graph trace. Okay? And it's going to bring up this spider-looking thing. So what we're going to do is we're going to take it and we're going to pull it along each step, and you're going to notice in the lower right-hand corner where it says f of 1, 0, 0, as we move our trace, that point is actually going to change. So our x value, when we move it to the right, so moving the other direction for me, right, when I move this to the right, my x value gets larger, and as it approaches 1, when it hits that value of 1, or it hits, thanks, Mike, when it hits that value of 1, it pops up to the next step, okay? So what you can do with your students is allow them to play with that graph trace and let them figure out how the function is changing instead of you telling them that at that value we bump up. At the next value we bump up. So that's a nice, quick, easy way for the kids to kind of start thinking about what this step function actually means. Now, of course, there's a whole bunch of different step functions that we can actually graph. And Blake did show you how you can adjust that equation by double-clicking on the label. You can also adjust the equation by bringing back up that function bar. The quick, easy way to bring back up the function bar, or where we originally graphed it, would be to hit Control-G, G standing for graph. Okay, so we're going to hit Control-G, and then you're going to hit your up arrow on your nav pad, and it's going to bring you back to your original function. You can adjust it from here. So this is where we kind of make that connection with translations if we talk about horizontal and vertical. And now you ask your kids, okay, if I wanted to horizontally translate this 2 units to the left, what would I need to do to this equation? And let your kids figure it out. Let them try it and see how it changes it. So, Blake, you want to be my kid?
Certainly.
Horizontally translate 2 units to the left, please. Great. Okay. So now, if the kids weren't sure, because sometimes it's hard to see from one to the other, they can go back in and graph that original parent functions themselves and to see how it shifted from one to the other. But this is a horizontal translation, 2 units to the left. Blake got it correct. You get another Jolly Rancher from me. So this is a really quick, easy way for students to kind of get this greatest integer function. Now, in my classroom, I actually like to use the step function in connection with some ELA. I actually do make my students write. They hate me for it, but I make them do it. And what I ask that they do is I ask them to come up with real-world examples of where we would use step functions. So I actually force them to write a story using examples of step functions to describe it. So where do we see step functions in real life? What kind of situations do we have step functions occurring? Anybody have any ideas? Where do we see step functions in our own lives? This is a tough one for the kids too. They really have to think about it. Well, I don't know if postage, sure. Good. Yep, postage is one of them. Buying quantities of things, great. The data plan on my cell phone, yes. That is a big one, and the kids really understand that. Car rental, that's a wonderful one. Parking garages, there's another one. So what I have kids do is I actually have them create a story, create a paragraph about whether they were talking on their cell phone and they spoke on their cell phone to a friend for 58 minutes, but they got charged for an hour. So what they do is they come up with these stories and they create their step functions according to their story. And it actually makes it fun for them, and it brings the math to life. So that's how we graph these step functions on our calculators. And it's really not difficult. You just have to remember it's the int and then in parentheses x. Okay, so we're going to get off of this, and we need to skip back. We actually have something really great to show you guys as far as student work from piecewise. So we're actually going to bump backwards if that's okay.
Yeah. There's a gentleman by the name of Tom Reardon. He is, I believe he's a T-Cube national instructor. And he was very, very kind to send us some examples of some student work that some of his students have done with transformations. And so I'm just going to pull up an example file. Let me see. Let's go and let's open that really quickly. It's on my desktop. This is an example of a project that he had his students do. Anyone take a guess at who this is? Yes, very good. All of this is done with piecewise functions and some specific criteria that he had for his students. And so I'll show you the document that you will have available through the TKids website, I believe. It will be posted with the resources for this webinar. But this is basically these are basically the instructions. And so here Tom gives a list of all of the basic graphs that the students must use. And you can see there's 13 different requirements here as far as the basic graphs that he requires, and then some additional criteria listed here. I think this is a very, very nice way to engage your kids in some creativity, and at the same time really making them think and analyze everything that we have been talking about regarding domain and range and piecewise functions and transformations, and how all of those work to affect the graphs of those functions.